have here is a weak regression. Weak because the R-squared is not very large. And second, we get into the F-test to find out if the regression is significant, regardless of the fact that it is weak. Alright, so we start up our hypotheses, which are always the same. Null hypothesis that all the beta sub i's are equal to 0. Alright, and to be perfectly plain, the beta I being 1, 2, or 3, that means that no x in the regression explains y. Alternatively, at least one of these beta i's, 1, 2, or 3, is not 0, which means at least one x explains y. Next step is to concern ourselves with the degrees of freedom so we can get our critical value. If this k at n minus k minus 1 degrees of freedom, right, k is the number of x variables in the regression. There are 3 of them in this regression. N is 25 minus 3 minus 1, and that's an f with 3 and 21 degrees of freedom. Going to our tables, 3 and 21, alright, 3 in the third column, and 21 in the denominator degrees of freedom, so our critical value is 3.07. Okay, so decision rule, if fcalc is less than or equal to the critical value of 3.07, we'll say simply that the regression is insignificant. It means that the explanations given by the variables in the sample are nothing better than random numbers could provide. If fcalc is greater than 3.07, then the regression is significant, and so the explanation provided by the data is better than just what random numbers would provide. Alright, and if you want to see the little representation of that, less than 3.07, the regression is insignificant, greater, significant. Alright, next step is fcalc. We must use the R-squared formula instead of the sum of squares formula, since we don't have, or we weren't given the sum of squares, for instance. So it's r squared divided by k, all that divided by 1 minus r squared divided by n minus k minus 1. Alright, where r squared is 62.56%, but we'll have to translate that back to a proportion to use it in this formula. So that's 0.6256 divided by k of 3. Then 1 minus 0.6256 divided by 21. Alright, and that works out to be approximately 11.7. 11.7 is clearly much greater than the 3.07, the critical value. So this regression is significant. So regardless of the fact that the R-squared showed the regression was weak, it is still significant, and as it's significant, it is still valuable and useful for us to predict the y variable and to explain how the y reacts to the x variables. Alright, the next part of our technical analysis will be the last step, which will be the t-tests to see if all the x variables are significant. Since the regression is significant, we expect at least one of them to be significant. The null hypothesis that we can use for the three t-tests: beta sub I is equal to 0. And again, remember, I is 1, 2, or 3. That means that x sub I does not help explain the y. Alternatively, beta sub I, again 1, 2, or 3, is not 0, which means that x sub I does help explain y. Degrees of freedom for the t-test: n minus k minus 1, same value that we used in the f-test. So there's 21 degrees of freedom. We'll use the standard alpha of 5%, 2.5% each tail. Going to our t-tables, 21 and 2.5 is 2.080 for the critical value. And we'll therefore write down our decision rule. First, if t-calc is between plus and minus 2.080, we'll say that the particular x variable x sub I is insignificant. Alternatively, if t-calc is not between plus and minus 2.080, the particular x variable x sub I is significant. At this point, we need to do our calculations. So first, for x1, t-calc is beta hat 1 divided by standard error, yes, the beta hat 1. Beta hat 1 is negative 1.176 divided by standard error 0.3156, and that's negative 3.726, which is clearly not between the critical values of plus or minus 2.080. So x1, the dummy variable for marital status, is significant. So marital status does significantly help explain the amount of TV watched per day. x2, t-calc beta hat 2 divided by s beta hat 2, and beta hat 2 is 0.03876 divided by standard error of 0.03193, and that works out to be positive 1.214, and that clearly is between plus or minus 2.080, right, so that t value is too close to 0, hence the beta coefficient is too close to 0, so it could be 0, so x2 is insignificant. The age of the senior citizen does not significantly help explain the y. And then finally, for x3, t-calc is beta hat 3 divided by s beta hat 3, and beta hat 3 is negative 0.1523 divided by standard error of 0.05011, and that's a negative 3.039, and that, again, just like the first variable, is not between the critical values of plus and minus 2.080, so that beta hat 3 is sufficiently far enough away from 0, so x3 is significant. The number of years of education of the senior citizen does significantly help explain the amount of TV watched per day. Alright, and that's the end of the technical